Don't just read to me. Give it to me in your own words. What's an angle?
Two rays connected by one endpoint.
Good. Two rays that connect by an endpoint. That's it. Pretty straightforward. Okay, and then the ray is made up of the rays are called what? In an angle? Sides, and that point that they share in common? Vertex. Very good. If you have one of them, it's a vertex. If you have two, they're vertices. Just to make sure our English is correct. Okay, so that was the gist. Question?
Does an angle have to be the common endpoint of two rays?
That's what he said.
I know, but like in a rectangle there are angles too, but
I don't know what that word means.
okay.
A square-shaped plane.
Right? So what are you asking?
Like
Can you ask the same question without using the R word?
the sides of that shape
The sides of that shape, okay. Yeah,
are
yeah, like that, like the whiteboard in the back there.
Yeah.
Okay, so if we've got a whiteboard in that, we got a whiteboard shaped object.
yeah, but like the sides aren't rays. They don't have curves.
Correct, but you can chop off those rays and still get that thing we call an angle. So sometimes an angle will be represented by two segments that share a common endpoint, but by pure definition, they're rays because it goes on forever. Okay, good question. All right. The worksheet then the slideshow had a bunch of other stuff in there that we'll start to work out when we go over the homework. In particular, how to set up algebraic equations with relationships that are created within those angle measures or those angle pictures. For instance, an angle within an angle. We also, well, tell me, what else did you learn from the slideshow? Sarah, right?
Yeah.
Go.
There's four types of angles.
Yeah, what are they?
Acute, obtuse, right, and straight.
Good. Can you tell me what each of those are?
Acute is more than more than 0 degrees, but less than 90.
Good.
An obtuse angle is more than 90, but less than 180.
Perfect.
So right angle is exactly 90,
Uh-huh.
and straight is exactly 180.
Is there say one? I'm sorry.
It's exactly 180 degrees.
Good. Which looks like what? What's a straight angle look like?
Straight line.
Good. Well, all lines are straight, so we can stop using straight line because that's a redundancy. Okay, you're just repeating yourself. You're saying the same thing over and over again. Nobody got that joke?
You said over and over.
Yeah, I was being redundant when I was talking
So
about
it's ironic, you know.
that.
Said over and over again.
So it's redundancy, we're talking about redundancy something.
Correct. So, Sarah, let's suppose I got a right angle up on the screen there. How do I know it's a right angle?
There's a little box.
Yeah, you got that little box in the corner. So you can't assume that things are right angles. If I turn around and look at that whiteboard shaped thing, I'd like to think that the corners in that whiteboard shaped thing are right angles, but I don't know that. I don't know it unless somebody tells me those are right angles. Somebody tells me they're equal to 90 degrees, or somebody puts a little box in the corner there. Okay, so don't assume right angles because you'll get into a whole bunch of trouble. For our purposes in this class, we seldomly, if ever, talk about angles greater than 180 degrees. We're going to deal only with angles from 0 to 180. Okay? Anything else? How about some notation? How do we denote an angle? If I'm talking about angle, let's say CAT, how would I write that? Oh, look at that stuff. What's the symbol for an angle? That's a little angle.
So we measure acute angle.
There you go. And there was a thing in the slideshow about the difference between this and this. It's the same comparison we talked about, the difference between this and this. This is a physical object. It's actually a segment. This is the length of the segment. This is the measure of the angle. This is the actual angle. Okay, so that's a physical object. That's a number using degrees, and hopefully you're all familiar with the degree symbol. Okay. So the rest of that stuff in that section we can glance over, and we'll talk about more tomorrow when we go over the homework. Let's move on to 1.5, which is now going to take angles that we've talked about, those 4 angles that Sarah mentioned, and we're going to combine them into pairs of angles. Okay. So those were types of angles in 1-4. This is pairs of angles in 1-5. And there's a whole bunch of them. There's a dot right there. Trying to work your smartboard reading. There we go. Pairs of angles. We did that already. Said that, said that. 5 pairs of angles. Here's the first one, adjacent. What does the word adjacent mean? Go.
Next to each other.
Next to each other. There you go. 2 angles that are next to each other. However, notice in the definition, they have to share a common vertex, and they have to share a common side, and no common interior points. Oh, one other thing I forgot to mention while you're writing that down. When you name an angle, the middle letter must always be the vertex. Okay, so if I'm talking about angle CAT, I know that A is the vertex. So for instance, we're looking at angles up here, PQR and angle RQS. How many angles in that picture, by the way?
3.
3, correct. The other one is PQS because you can combine those 2 smaller ones. Okay, simple. Two angles next to each other because adjacent means next to. This one's pretty important. Vertical angles. Has nothing to do with the vertical like you know it of up and down. I don't know why they call them vertical angles. They just do. We take 2 lines and we intersect them. And sometimes those lines will be raised. And sometimes those lines will be segments. But we intersect 2 straight things. And it's going to form 4 angles. Every time it's going to form 4 angles. The angles across from each other are what's called vertical angles. And you see in this picture I've got 2 pairs. 1 and 3 are vertical angles. 2 and 4 are vertical angles. Okay, we good? All right. Linear pair. Okay, so linear pair takes the idea of being adjacent angles, but they're adjacent angles on a line. Okay, so forget about this stuff down here. If I just take angles 1 and 2, I take a straight, I did it now. I just told you not to do it and I did it. I was being redundant. I was repeating myself. Take a line, draw a ray up from it, it forms 2 angles. Like it says in the definition, the non-common sides have to form a line. So if we look at angles 1 and 2, 1 and 2 are a linear pair. What's the measure of angle 1 plus the measure of angle 2? Tell me your name again. Joanna. 180. Okay, because it's forming a straight line. I did it again. It's forming a line, also known as a straight angle, which is 180 degrees. So 180 here, 180 here, 180 here, 180 there. It doesn't tell you how big any one of the individual angles are. It just tells you that if I add those 2 angles together, I'm going to get 180. Okay? Dos más. See? Bueno. But first, let's take an example. Before we actually start doing the work on this problem, let me ask you a question. First of all, what kind of angles are those? What pair of angles do we have illustrated in that picture? Go ahead. Those are vertical angles. What's the relationship between vertical angles? Go ahead. Why?
Because 16 minus 20, which is like CAT and 16x minus 20 are a linear pair.
Uh-huh.
And then 12x plus 7 and the over 1 are a linear pair. So those 2 are next to each other.
Everybody follow that? Are you convinced? Okay, let me simplify that a little bit better. Not even simplify, just explain it a different way. So I'm going to put numbers down in here. Here's another way you can name angles. You don't want to use all 3 letters, then put numbers down in the corners down there. We can talk about angle 1, angle 2, angle 3. Okay, so what Joanna said was angle 1 plus angle 2 equals how much? $1.80. And angle 2 plus angle 3 equals $1.80. Everybody with me? Any confusion? Linear pairs there, we're good to go. Now we do a little bit of algebra. The left sides equal the same right side, so I can set the left sides equal. Angle 1 plus angle 2 equals angle 2 plus angle 3. Do a little bit of subtraction. Whoopsh, whoopsh. What are we left with? Angle 1 is equal to angle 3. Notice that little business I did over there is not dependent on how big or small any of those angles are. It works for all situations. So in essence, we just did our first proof, which we'll do quite a bit in this class. And we proved that those vertical angles have to be equal. Okay, so now we know the vertical angles are equal. How do I answer the question? What do I do with those 2 measurements?
You set them equal to each other and solve the equation.
Beautiful. 16, x minus 20 is 12x plus 7. Doing a little bit of math here. Let's see, 4x is equal to 27. Well, this isn't pretty. 27 fourths. Did I do something wrong?
No, I got the same thing.
No, we're good. Okay, solid. Oh, hold on. I have to find the measure of CAT. All right. Now that I know what x is, how do I find CAT?
But you substitute x for the angle.
Which one?
For, it doesn't matter.
Which would you
I
prefer?
mean, 16x minus 20.
You want to go up on the top one?
Yeah.
Be sure.
Wait. Whichever one.
Would you substitute it into like, okay, we could do 16x minus 20, and then we would do equals 180.
Good. All right, so let's do this first. Let's take that and put it in here. 16 times 27 fourths minus 20. Oh boy. Okay, I can do that. Can't say, I'm a math guy. I'm good. That's if there's 108. Did I do that
I got
right?
88.
Yeah, 88 is final answer. I subtract 24. So we're good?
Yeah.
Okay. All right, so that tells me how big this angle is. So this is 88. Then what did you say I should do?
Then you would do like minus x equals 180, and then you would solve for x.
Nice, nice. That would make this 180 minus 88 is 92. It's not?
Well, that's an acute angle.
Oh, I was just going to ask that question. What's wrong with my picture?
Should be flipped, shouldn't
Should be flipped. Right. So here's the problem. My picture doesn't match the numbers. Okay, everybody understand the problem that he just brought up? This is an acute angle, but it has a measure that makes it obtuse. This is an obtuse angle that has a measure that makes it acute. Which one do I trust? The numbers or the picture? Always trust the numbers, yes. Okay? Sometimes the pictures are just generic pictures. Sometimes I purposely draw the pictures incorrectly. Sometimes I'll just draw the pictures and not give you any clue. I might just make them look all like 90 degrees. Trust the numbers. Our math is solid here, so these measurements must be correct. Okay? We good with that? Excellent. Prove that vertical angles are congruent. Still think we have 2 more angle pairs, right? Yeah. Supplementary. 2 angles that add up to 180. So all the angles we talked about so far, up until supplementary angles, were dependent on where they were located. Okay, so adjacent angles had to be next to each other. Linear pairs had to be next to each other. Vertical angles had to be across from each other. Supplementary angles don't care. If you've got 2 angles that add up to 180, They're supplementary. One could be on the board at the front, one could be on the board in the back, they're still gonna be supplementary. A 100-degree angle is always supplementary to an 80-degree angle regardless of where they are. Okay, so location is not important. If a supplementary pair of angles add up to 180, what do you figure complementary angles are? Who's talking? Is that you? What'd you say? Yeah, they add up to 90. There's our 5 pairs of angles. We will get more later, but for now, that'll get you started. That's a pretty good basic introduction. And then we get to take a look at how are we going to use these things. I got a couple examples for you. All right, so we have 4 types of angles: acute, obtuse, right, and straight. We've got 5 pairs of angles: adjacent, linear pair, vertical, supplementary, complementary. Now, how do we put all that together? Well, we're going to take those ideas, and create a couple different problems, in particular some algebraic problems. So let's start with that guy. Now, as you're starting these problems, you would ask yourself, what pair of angles am I looking at up there? So just to make our lives a little bit easier, I'll put an alpha down in there, and I'll put a beta down in there. Time to start learning the Greek letters, kids. Alpha looks like a fishy, and a beta looks like a bee with a tail. What's the relationship between angle alpha and angle beta? Tell me your name again.
Caroline?
Caroline, I'm still learning names. I'm sorry. It's so rough when I'm not passing papers. If I was passing papers back, I'd have you all stone cold. Go ahead, Caroline.
Alpha and beta add up to 180 degrees.
Good. Which pairs of angles does that represent, Caroline?
HIK and...
No. I mean, sorry. Let me back up. I didn't ask my question correctly. Of the 5 pairs of angles that we talked about, what pair are alpha and beta?
Alpha would be an obtuse, and then beta would be an acute.
Those are types of angles. I want pairs of angles.
They're complementary, or wait, supplementary.
Good. They're supplementary. What else are they?
They're adjacent.
Good. One more.
I'm not sure.
Hey,
Alyssa.
Alyssa. They're a linear pair, correct. Okay, so that picture right there represents 3 of the 5 pairs we've talked about already. They're adjacent, they're a linear pair, and they're supplementary. All right, Caroline, back to you. So you've established that those are supplementary, meaning they add up to 180 degrees, correct?
Mm-hmm.
What equation would I then create?
Would you do 10x plus 5 plus 4x,
Minus 5?
or minus 5, sorry, plus 4x plus 3 equals 180?
Would we? Yes or no?
Yes.
Yes, very good. All right, solve that, everybody. Oh, I need some help. Is it a nice, pretty answer? 13 exactly?
Yes.
Oh, you think I planned that? Awesome. Now, just for giggles, let's take this and put it back in. Now, not only do we have to put it back in because it asks you to find the angle measures, but it'll also be a good way to check and see if we did the problem wrong. Let's suppose I did my algebra wrong and I got 5 as an answer. Everything would look fine, except I did my math wrong. But anyways, I get x equals 5. When I plug it back in, it'll become evident when I made a mistake because those angles won't add up to 180. So I put 13 in here. 4 times 13 is 52, plus 3 is 55. Can somebody confirm that?
Yes.
Outstanding. So hopefully, this is 125 degrees. 10 times 13 is 130 minus 5. Oh, yeah. Beautimous. Good. So we found the value of x by setting them equal, or sorry, adding them up and setting them equal to 180, and then plugged it back in to confirm that yes, in fact, we do have the correct value for x. And again, if I had the wrong value, like 5, if I put in 5, I'd get 45 and 23. And 45 plus 23 is not $1.80. So you made the mistake. There's another one. So we're going to go through the whole process again. Tommy, you're helping me this time. What's the relationship? Let's go. Tommy, you know any of the Greek letters? Can you name one?
Alpha, beta.
Cheater. None others? Anybody know any other Greek letters? Give me one.
Omega.
You want me to use a lowercase omega? All right. Lowercase omega looks like a fat W. Looks like it's got a growth on its side. You got another one?
Gamma?
Gamma. Nice. Gamma's good. Fishy on its head. Okay. These are lowercase Greek letters, by the way. We normally use those to denote angles. Because an uppercase omega looks like this. And then an uppercase gamma looks like a hangman's noose. Like you're going to play hangman. Okay, but we're doing these. All right. Tommy, I was talking to you, right? Good. Sorry, I got sidetracked. Tommy, what's the relationship between omega and gamma?
Complementary and adjacent.
Woo. Complementary and adjacent. I've forgotten what complementary means.
They add up to 90 degrees.
Good. So what equation would I create?
2x plus 2 plus x plus 1 equals 90.
Solve. Whoops. Uh, 29. No.
Yeah.
29. Yeah. I was just testing. Good job. Well, that's easy. That's 30. 29 times 2 is 58 plus 2 is 60. Hot diggity. Pretty sure we did it right.
Yeah.
Right. Notice in this picture too, if we go back to the first example that Caroline helped us with, our picture is accurate. This is an obtuse angle. It has an obtuse measurement. This is an acute angle. It has an acute measurement. That won't always happen. Okay. Are we good? Now things get a little nastier. So let me read it to you first to tell you how scary it's going to be. The measure of the supplement of an angle is 60 less than 3 times the measure of the complement of the angle. Woo-hoo-hoo. Okay, before we get into this, let me ask you a question. We're going to take an angle. We'll call that angle measure x. Okay? Wait, hold on. Let's even do it simpler. Let's take a 10-degree angle. 10 degrees. How big is the complement of that 10-degree angle? In other words, how big is the angle that would be complementary with that 10-degree angle?
80 degrees.
80 degrees. That would be its complement. Good. How big would its supplement be?
170.
170. Everybody with me?
Yeah.
No? Who'd I lose? Complementary angles are two angles that add up to 90, right? So if one is 10, the other one has to be 80, because 10 plus 80 is 90. Supplementary angles are two angles that add up to 180. If one is 10, the other one has to be $1.70.
Alright, gotcha.
Dig?
Yeah.
Suppose we have 1 degree angle. Complement is 89, and the supplement is 179. Okay, good. You guys got that under control. Now, let's try x. If the angle measure is x, how big is the complement to that angle? Is that it? We don't want to introduce another variable.
90 minus that.
Beautiful. Who said that? Jalen, is that you? Nice. And so since you're on a roll, what would this supplement be?
180 minus that.
Perfect. These are important to remember. The reason they're important to remember is to solve a problem like this, if you can remember those two things, you literally just write exactly what the sentence says. Okay? So let's give it a shot. The measurement of the supplement of an angle. How do I express that?
Wouldn't it be like, M and then the angle sign?
Mm-mm.
No.
Nope. Yeah, use it.
Yeah, I just see the whole equation.
No, I just want that part. The measurement of the supplement of an angle.
180 minus
Good. 180 minus x. The word is the same thing as equals. Is. How do, what? I didn't ask a question yet. What's capital Peru?
What?
What's capital Peru? Anybody?
Lima City.
Lima, very good. Okay, 60 less than. How do I write that? What function is less than? Subtraction. Okay, Gesundheit. Minus 60. I'm gonna stick that on the back end so it's out of my way. 3 times the measure of the complement. What function is times?
Multiplication.
Multiplication. 3 times.
Yeah.
Right? 3 times. How do I write the complement of an angle?
90 minus x.
Beautiful. There's my equation. Then you can go and solve that equation. That's not too bad to solve. Find the value for x. That'll tell you the measure of the angle. And be careful to be careful to read what the problem asks you. Sometimes I'll just ask you what's the measurement of the angle. Sometimes I'll ask you what is the complement of the angle. How big is the supplement of the angle? Those kind of things will pop up all over the place. Solving that, I get a $1.80 minus x is equal to 270 minus 3x minus 60. So let's bring this over here, would be 2x, and 2 says 210, and 210 minus 80 is 30. I do my math right? Beautiful. And so there's the angle measure. Its complement would be 75, and its supplement would be 165. But again, don't let those sentence problems freak you out. Just write exactly what it says. If you can remember that the complement is 90 minus x and the supplement is 180 minus x if you don't know the measure of the angle. Okay, so this whole business of an angle we're going to call x. We good? Good. I don't know why that's there. Let's try that again. There we go. Perpendicular lines. Anybody know what the word perpendicular means? Anybody know what the word perpendicular means? Thomas. Thomas.
This is when they're like exactly like that.
Exactly like that. How are you going to write that on the test?
Like there are 2 lines that go together to make 4 right angles.
I like it. What were you going to say? Tell me your name again.
Oh, Grace.
Grace, what do you got? Same thing. So you stole your idea. Okay. Good. 4 angles, or sorry, I said it wrong. 2 lines, or they could be segments or rays or any combination thereof, that intersect and form 4 right angles. So if there's 4 right angles up there, why did I only put 1 box? Thomas?
Because they're like all the same thing. Never mind.
Yeah.
They're all adjacent to each other, so that means they're all right angles.
Correct. They're all right angles. And so to save ourselves time, we just put 1 box in there. That's 90, that'd be 90 because we already showed. What kind of angles are these? Other than right, yeah, what pair of angles are these? Vertical angles. So these are 90. These 2 are supplementary. If one's 90, the other one has to be 90. These 2 are supplementary, these 2 are so we get 90 there. So the way we do that is we just write 1 box down there and it gives us everything we need. Okay? So then my pen stopped working? Hopefully, oh, there we go. 2 lines that form 4 right angles. I think that's almost exactly what you said verbatim, right? Nice. There's a new symbol, upside down capital T. It means perpendicular. So that's saying the line L is perpendicular to the line M, meaning their point of intersection is going to form a right angle. Because again, we're lazy and we don't want to write big words like perpendicular out, so we create a symbol to represent that business. Okay? That's what I just said. All right, time to run with the big dogs. We want to find x and y, given that KO and HM are perpendicular. So first things first, I'm going to put a right angle symbol in there. KO is perpendicular to HM. So I'm going to put a right angle there. And give you a second to look at that picture and figure out how we're going to attack this problem. What time are we out of here, by the way?
53.
50, oh, holy smokes. All right, we're going to pick it up a little bit. How big, yes, sir. Go, give me something,
Well,
but talk quickly.
9x plus 3x plus 6 equals 90.
Perfect, okay, stop there for a second. Angle KJH is 90 degrees because if this is 90, this also has to be 90, and then we have a problem like Tommy helped us with. Perfect, there's one equation. That'll solve x for us, and we're good to go. How do I solve for y? Name, please.
Oh, Kira.
Kira.
Yeah. 3y plus 6 equals 90.
Perfect. Since this one is 90, this one is also 90. We get 3y plus 6 equals 90. Solve for y. We're good to go. All right. I think we're done. But let's. Oh, we're done. Beautiful. Okay. So tomorrow, damage control. I know some of you struggled with the homework last night. Maybe what we talked about in class will help you clean it up. If not, that's okay. That's what the homework is for, is to learn from. You have